In this session, the clock operation of STU, which is supplied by Dasan Corporation, will be discussed. Firstly, this will discuss that the current STU software version 1.03/5, how the STU clock behaves in 4G network and 5G network. Now, the STU clock behavior in 4G network. When GPS receiver linked to STU is in normal status, GPS receiver is primary clock of STU, provides clock as grandmaster to LIU in STU by receiving clock source from satellite. In terms of LIU in STU, for converting CIFRI signals from LLH to eCIFRI and transmit them over Ethernet, a RIM manager that is LIU is included in the STU in the form of FPGA. LIU included in STU as the form of FPGA has LTO star software applied. The STU provides a physical link for LIU within STU. If something went wrong for some reasons, for example, decreasing in satellite signal, GPS cable connected badly to STU, GPS disconnection, so that GPS cannot be functioned properly as primary clock of STU, then STU would be operated as PTP slave mode of G.8275.2 and provide LIU PTP clock. Have a look at the pictures. On the left side of diagram indicates the general status of GPS connected to STU. And on the right, the diagram shows GPS that cannot function as primary clock of STU. General status of GPS. As you can see, there is a 4G TOR NGC and the 4G TOR connected to STU, which is supplied in the field. GPS is connected to STU to receive satellite signals. LLH connected to row CIFRI interfaces of STU. In this figure, the clock source becomes GPS since STU initially uses the primary clock as GPS. By the signal received from GPS, the STU will be locked in the clock state. After that, STU provides clock to LIU in STU. This is the case when GPS reception connected to STU is in general operation. On the right, let's look at the clock operation in situations where GPS connected to STU is not available. For instance, satellite signal degradation, poor GPS cable connected to STU, poor GPS connection, etc. In the situation where clock source cannot be received from GPS connected to STU, STU is transferred to secondary clock instead of GPS, which was the primary clock. This means that you will receive a clock source from another grandmaster, not another GPS. Since STU receives clock sources from grandmaster installed on GC side or CDC, STU becomes slave, meaning by operating in the PTP slave mode of G.8275.2, the STU is locked. After that, the clock is provided to the LIU in the STU. So you need grandmaster on 4G network. Let's move on to page number 4. The current STU software version is 1.03/5, and I will explain the clock operation of STU in 5G network. In a 5G network, when the GPS connected to the STU is received normally, the STU receives the clock source through the GPS. The primary clock of the STU to the NLTOR for the northbound and to the 5G new radio device for the southbound G.8275.1 Grandmaster as a clock. In other words, STU operates in PTP boundary clock mode. Boundary clock mode means receiving a clock from another device of the STU and providing the clock to another devices. In the figure below, the port receiving the clock from another device is marked as S and becomes the clock slave port, and the received clock becomes the clock master port marked with M that provides the clock to another devices. Let me explain while looking at the picture. First, let's look at the situation in which satellite signals are received by GPS on the left. As you can see, there is an LTOR in GC, and TOR is connected to STU installed in the field. GPS is connected to the STU to receive satellite signals, and STUC1216RO for 5G is connected below the STU. From this figure, the clock source becomes GPS, since the STU initially uses the primary clock as GPS. By the signals received from GPS, the STU will be locked in the clock state. After that, STU provides clock signals such as G.8275.1 PTP and SYNC-E to NLTOR for northbound and 5G sub-6 RU for southbound. This is the case when GPS receptions connected to STU is in normal status. On the right, let's look at the clock operation in situations where GPS connected to STU is not available. For instance, satellite signal degradation, poor GPS cable connected to STU, poor GPS connection, etc. STUs that cannot use GPS are not able to receive clock source from the connected GPS. The STU uses the clock received through the GPS connected to another STU connected to the NLTOR as a secondary clock instead of the GPS, which was the primary clock. At this time, STU will operate in the PTP slave mode of G.8275.1 and use G.8275.1 and SYNC-E. Clock is provided to STUC1216RO for 5G at the bottom of STU. STU operates in PTP boundary clock mode. Move on to the next. STU software version 1.03/005 has the following limitations. First of all, telecom profile G.8275 for 4G network and telecom profile G.8275.1 for 5G network cannot be applied to STU at the same time. This is because STU currently operates telecom profile based on system. Therefore, telecom profile G.8275.2 for 4G network and telecom profile G.8275.1 for 5G network must be used separately. Second of all, to change the telecom profile in STU correctly, rebooting the system is required. After saving the modifications that related telecom profile, DASAN plans to supplement the software in the future to enable simultaneous use of telecom profile G.8275.2 for 4G network and telecom profile G.8275.1 for 5G network. The following data describes the clock operation for simultaneous use of telecom profile G.8275.2 for 4G network and telecom profile G.8275.1 for 5G network. In the future, STU software will operate as follows for simultaneous use of telecom profile for 4G network and 5G network. Number 1. G.8275.2 and G.8275.1 to be used at the same time. When GPS is in normal operation, STU provides clock through other interfaces of G.8275.2 for 4G TOR and NR-TOR for G.8275.1. Internally provides clock to RIU and clock to NR wireless device with G.8275.1 provide. Number 2. If GPS is not available, the STU operates in sleep mode only in G.8275.1. In other words, the STU does not work in BC mode in G.8275.2. Number 3. The development schedule is expected to be 16 weeks from the start date. At this part, we will explain the clock operation when using telecom profile for 4G network and for 5G network simultaneously. In the figure on the left, when GPS is in normal operation, STU will provide clock with 4G TOR for G.8275.2 and G.8275.1 will provide clock to other devices through other interfaces of NL-TOR through connected NR-TOR. And STU will provide clock to RIU internally and clock to NR wireless device with G.8275.1. If the GPS connected to the STU is not available in the figure on the right, the STU receives the clock received from the GPS of the STU connected to another interface of NT-TOR, operates in PTP sleep mode, and provides the clock to the RIU and the STU. It will also provide a clock to NL wireless device with G.8275.1. Number 9. This is the clock operation when using telecom profile G.8275.2 for 4G network in STU software in the future. In the figure on the left, when the satellite signal is received by the GPS connected to the STU is normal, the clock is provided with 4G TOR, and the clock is provided to the RIU in the STU. On the right, there are two cases in which the GPS connected to the STU cannot be used. In the first case, when the GPS connected to the STU cannot be used, the STU is locked by receiving a clock source from the Grandmaster installed on the GC side or CDC. After that, the clock is provided to the RIU in the STU. In the second case, when the GPS connected to the STU is not available, the STU is locked by receiving the clock of the GPS connected to another STU connected to the same 4G TOR, and the clock is provided to the RIU in the STU. It has not been decided how to work with the above. However, doesn't recommend case number 1. Case number 1 is recommended because only one Grandmaster IP address needs to be configured in the STU, and the Grandmaster IP is never changed, so it can be used more safely than case number 2. Case number 2. The adjacent STU IP address should be configured in the STU as Grandmaster. STU gets its IP address via DHCP, so it is difficult to configure with other STUs. In addition, if the STU is replaced for maintenance reasons, it is a problem in operation and management, because other STU configurations for Grandmaster IP must be changed. Page number 10. This is the clock operation when using telecom profile for 5G network in STU software in the future. The figure on the left provides a clock with 4G TOR when satellite signal reception is normal to the GPS connected to the STU, and provides the clock to the NR wireless device connected to the STU. On the right, when the GPS connected to the STU is not available, the clock is provided through the GPS connected to the adjacent STU connected to the same NR TOR, and the clock is provided to the NR wireless device connected to the STU. This is the end of the presentation. Feel free to ask anything.